We are all wild creatures, as Darwin pointed out. A reminder that despite humanity's technological advancements, we remain truly fundamentally connected to the natural world. My decision to study the chemistry of climate change came from both literature and current events. Wallace Stegner's Wilderness Letter emphasizes that humanity is deeply embedded within nature and therefore responsible for its preservation. Discussions within the Placentia Wilderness School District, along with my classmates' involvements with the Climate Coalition Advocacy Group, showed how some adults in the school district believe this issue to be false and just a political concern. My political science professor, Audrey Deschald, also shed light into interest groups spreading logical fallacies about climate change. In whatever way one perceives the issue of climate change, or the many public opinions held about it, behind the debate on this issue, it's truly astounding to consider Stegner's perspective on the fact that humanity's relationship with nature not only reflects our values, but our willingness to preserve the world beyond ourselves. So what really is the issue here at hand? David Attenborough, in his lifelong career, does a great job of explaining and observing climate change in real time. So he shares that ice core and atmospheric temperatures are on the steady rise. CO2 accumulation is changing the Earth's radioactive energy. There are feedback loops being thrown off, and there are unlinear changes, either minor or drastic. And he states that these observations that he's seen demonstrate the long-term impact of changing atmospheric chemistry on Earth's climate. So let's learn about the process of pollution. There is combustion, so fossil fuels like gasoline and coal undergo combustion reactions to produce energy. So the process to make energy to fuel our homes, cars, and electricity and things like that require combustion of fossil fuels. And then there's the release of gases, carbon dioxide, methane, and nitrogen oxide, which are released into the atmosphere. So during the process of combustion, there are also gases involved to make the energy, which then all get released into the air because they have nowhere else to go or be stored. And then heat is trapped. These gases absorb infrared radiation and prevent from escaping from the Earth's atmosphere. So the release of gases during combustion all gets trapped because they are interacting with infrared radiation. And then there are atmospheric reactions. Pollutants start to react to sunlight and chemicals, forming smog and ozone, or O3. So all of this gas that is trapped becomes into heat as there's radiation, and so then it can't leave the Earth. And so they stay long enough to be able to react, chemically react with sunlight and other things in the air. So then all of this has an effect on environmental systems. This causes rising temperatures and chemical changes that disrupt oceans, weather patterns, and ecosystems. So weather patterns can mean like less rain or even more rain within communities or different areas of the world that are unusual or abnormal. And then there's intensified change. All these 5 steps go into more and more of heightened type of climate change that we see more over time. Alright, so what is a good example of carbon emissions? So an example of pollution can be car emissions, hydrocarbon or fuel, plus O2, while turning on your car and driving or getting it to move, turn into the end of the chemical equation, which is CO2 plus H2O plus energy. Now, it is important to note that this energy is the very important component or factor that is helping the car start up and move from point A to point B. But then there's also this negative aspect or component to this energy, or this end of the chemical equation, which is CO2. So gasoline used in car engines is a combustion reaction. In this reaction, hydrocarbons from gasoline react with oxygen in the air to produce carbon dioxide, CO2, water, H2O, and energy. One of the primary chemical significance of the combustion of gasoline is that it releases energy that is stored in chemical bonds and can be converted into heat and mechanical energy. This heat and mechanical energy provide the power to move vehicles, and they are essential for making modern-day transportation a reality. While combustion of gasoline has provided these useful norms of energy, the production of carbon dioxide from the combustion of gasoline also provides contributors to long-term environmental challenges. This is all stated in the Union of Concerned Scientists, Car Emissions and Global Warming. Alright, so what kind of consequences can we see with long-term atmospheric changes? We can see extended periods of dry weather across much of the United States, which lead to a decrease in available drinking water as well as a decrease in crop production. Flooding creates damages to structures and takes away homes from people. High temperatures along with changes in precipitation patterns result in less crop yield and less food for all. So, as we mentioned here back previously in the slides, disruption in weather patterns can be related to precipitation patterns, which is how much rain you're getting, or the abnormality of the rain amount. Maybe there's too much rain in the deserts, or there's not enough rain in the Amazon rainforests. That could be precipitation patterns that are different or disrupted. And when a farm needs water to provide for the plants, but they don't have enough water because of droughts or less and less rain, then there's going to be less food, and communities or societies are going to start competing for these resources. A shortage of water, food, and stable housing will create scarcity for all. So a example of this can be seen in the Hawaii floods that we saw in March and April of this year. Actually, there were massive floods, flooding people's homes in Hawaii, and many had to move out from the island to find different housing in the city in the mainland United States. But the scientists believe that the cause of the flooding was mainly ocean acidification from CO2 emissions in the air going into the waters near the Hawaii oceans. Alright, so what are some chemical solutions to climate change? We can see this in catalytic converters on cars. An exhaust system is, called catalytic converter relies on catalysts to accelerate chemical reactions that lower harmful emissions from vehicles. Toxic gases such as carbon monoxide and nitrogen oxides will be converted by the catalytic converter into less harmful materials like carbon dioxide, nitrogen, and oxygen. A good example of this that is helpful on cars is Ford F-150s. These larger trucks and transportation vehicles that have a higher combustion rate need more carbon emissions, and so these converters will be helpful in these cars. These catalytic converters were invented in 1975 by Environmental Protection Agency and were placed into law as a requirement for all gas-powered or hybrid cars to have these catalytic converters to prevent more emissions. We can also see carbon capture and storage, or CCS, which is a process that removes carbon dioxide from industrial emissions or the air through chemical absorption, often using solvents that bind to CO2 molecules. The CO2 is then separated, compressed, and injected into underground rock formations where it is stored, preventing it from participating into atmospheric reactions that contribute to the greenhouse gas effect. Alright, so then let's take a look at some actions we or you can take that are simple and involve your daily life. So we can reduce electricity use by unplugging devices or turning off lights when we're not using them. A great example of this can be like electric powered fans to cool down rooms. If you're not in the room, maybe it might be a good idea to unplug it from the wall. Though the action of reducing electricity use lowers fossil fuels and combustion from power plants. A whopping 90% of Americans share they sometimes forget to turn off lights when they're leaving the area or their room or their house, which is a lot of people. Americans spend on an average only 55 minutes a day behind the wheel, so maybe considering the reduction of car use may be helpful. Can that short amount of time be replaced with a meaningful mode of transportation, such as biking? So, only 55 minutes a day is not that much. And to consider the fact that many Americans use their cars alone, so there are no means of carpooling with other people unless it is a special occasion. Maybe to drive to work, instead of driving every single day, it can be maybe replaced by biking or electric biking, which is not that much of a time difference and not too much of a committing thing to do. So maybe biking to work or walking 1 or 2 times a week can significantly reduce car emissions instead of just driving on your own every single day. All right, a second thing that we can consider is the third thing actually is the reduction of food waste. Fewer food disposals mean fewer methane (CH4) emissions from landfills, which are produced by organic matter decomposing conversion to gas via an anaerobic process without oxygen. Fewer decomposing organic materials result in lower production of greenhouse gases, helping to mitigate the greenhouse gas effect overall. Also, the food that is uneaten can go into landfill or dumps or be fired up, which also causes a lot of gases. Organizations like Food Forward dedicate imperfect food and produce, such as misshaped bell peppers, that aren't cleared for merchant sale and instead put towards volunteer donated food. 1 in 5 Americans experience food insecurity, so instead of wasting food, they get repurposed to feed families. All right. 35% of the food produced in the U.S. is unsold or uneaten each year, amounting to an annual loss of $408 billion to the economy. This is information from the Food Forward organization. They were established in 2009 as they noticed the influx of uneaten food or produce that just got thrown away because they were not pretty. Alright, these are my summaries and we're excited. Let's see here. Climate change is not a myth and human actions are accelerating the pace of change. Attenborough shares the planet is taking a turn throughout his life and his work career. There are many steps to reach pollution. Effects of pollution can not only be limited to ocean acidification, but also our basic needs and our resources like food and shelter, which are considered in psychology of Maslow's hierarchy of need. If those needs are not met, oh boy, we're not good. And then there are day-to-day actions we can do to reduce climate change. As Stegner suggests in Wilderness Letter, the loss of the natural world is ultimately a loss within humanity itself. And the chemistry of climate change reveals just how deeply human actions are now written into the atmosphere. Thank you. That was my presentation on Wilderness Letter reflecting Wallace Stegner and my current events around my world. I hope you enjoyed. This is by Clara Tsuchida. Thank you so much.